The last video was on circles. Area of a circle was pi r squared. Circumference of a circle, pi d. This deals with sectors of circles. Sector is part of a circle. It's a fraction of a circle. Here, the sector AOB has arc AB and two radii enclosing an area. The area is a fraction of the whole circle's area. So it's a fraction of pi r squared. So the yellow area is a fraction of pi r squared. The arc is a fraction of the whole circumference, pi d. And the angle is a fraction of the circle's angle, 360 degrees. In this case, it tells you the angle is 90 degrees. That means it's a quarter of the circle, because 90 degrees is a quarter of 360. Because this angle is a quarter of 360, the arc is a quarter of the circle's circumference, pi d, and the area here is a quarter of the circle's area, pi r squared. So we've got a quarter of pi r squared for the area, a quarter of pi d for this arc, and we've got 90 degrees here that told us it was a quarter. So here's from the information that the angle was a quarter of the 360, we know we've got a quarter of the circumference and we've got a quarter of the area. Here's another example. The angle this time is 60 degrees. Now out of 360 degrees, that's a sixth. So 1/6 of the circle. So the arc is a sixth of pi d, and the area is a sixth of pi r squared, because we've got a sixth of the circle. So the angle told us the fraction, and then we know they've got that fraction of the circumference and that fraction of the area. In general, to get the fraction, if you're told the angle, you make that as a fraction of 360 degrees. If you're told the arc length, make that as a fraction of pi d. If you're told the area of the sector, make that a fraction of pi r squared. Whatever fraction the angle is, the arc will be the same fraction and the area will be the same fraction. So they're equal. So basically, in the questions you're about to see, the key thing is find out the fraction of a circle that you have. So if you're given the angle goes over 360 degrees. This bit in red is getting the fraction of the circle. And if you want the arc length, get that fraction of pi d. The whole circle's pi d. If you want the area of the sector, get that fraction of pi r squared. So the angle gets you the fraction of the circumference or the area of the circle. If you're told the arc length, so if the arc length is the information you're given in the question, put that arc length over pi d, and that tells you the fraction you've got of the circle. And then you simply get that fraction of 360 degrees if you want to work out the angle, or that fraction of pi r squared if you want the area. So to get the fraction, you need information in the question. If you're told the area, make that as a fraction of pi r squared. Then get that fraction of 360 degrees if you want the angle, or that fraction of pi d if you want the arc. So key thing to get the fractions. So in this question here, we're told the angle is 60 degrees. Out of 360 degrees, well, that means we've got a sixth. So if it wants the arc length, AB, we want a sixth of the circumference, which is pi d. So there would be the first line of the working. To get the arc, it's a fraction of pi d. The fraction is from the angle 60 out of 360. Radius is 5, diameter is 10. Put that in the calculator and round as appropriate. 4 lines of working. Key thing is get the fraction, and remember when you want the arc, it's a bit of the circumference. Similar for area. This is same question, but asking the area. All that happens is you want a fraction of pi r squared. From the 60 degrees you get the fraction. So it's just instead of pi d, it's pi r squared. And radius is 5, you put in the figures. You just put that in the calculator and round as appropriate. Again, the same business with 4 lines. So one case it was pi d because we wanted the arc. The other case it's pi r squared because we wanted the area. These are the standard basic questions. It tells you the angle and you work out either the arc or the area of the sector. Questions can then be made a bit more difficult. This time it doesn't tell you the angle, but it does tell you the arc length is 6 centimetres. So you want from that 6 centimetres to work out what fraction that is of the circumference. So circumference is pi d. It's 6 out of pi d. That's the fraction of the circle you've got. It's 6 over pi d. D is 10, the diameter. And since we want the area, you want that fraction of pi r squared, with the radius being 5. So you just slot in the figures, d being 10 and r being 5. Put that in the calculator. It would work out the answer exactly 15. It doesn't require a calculator if you can spot that pi cancels top and bottom. And the 5 goes into the 10 twice. The 2 will then go into the 6. And it'll be 3 5s are 15. All that line there would simplify with cancellations. So this could be non-calculator. But the basic part is get the fraction of the circle. You look at the information in the question. You're told the arc. That's what's going to get you the fraction of the circle. And then when you want the area, you want the fraction of pi r squared. Now there's going to be a worksheet that's got all of these things in it. So first question is you're given the angle, find the arc. Second question is you're given the angle, find the area. These are the basic questions. Then turning it around, I haven't shown you an example like this, but it's the same principle. It tells you the arc. From that you can get the fraction of the circle. And you have to find out the missing angle. That is, you want that fraction of 360 degrees. And the fourth question, you're told the arc, but you want to get the area. That's just like the third example. Then you're told the area. So that's 7 over pi r squared gives you the fraction. And you have to get the missing angle. You want that fraction of 360. And similar question, you're told the area. So 252 is a fraction of pi r squared, it's a fraction. And then you have to figure out the arc length, so you have to get a fraction of pi d. Now some of these will come out exact answers. There'll then be two questions that follows, which really are pretty straightforward. 7 and 8 are about basically proportion. So I'm going to show you examples in these. It's simply this. Suppose you've got two sectors. Here, one's 60 degrees, one's 90 degrees. In terms of proportion, the smaller sector here at 60 degrees is 2/3 of the other sector, because 60 degrees and 90 degrees, 60 90ths cancels down to 2/3. So this smaller sector is 2/3 of the larger sector. So the smaller sector is 2/3 of the larger sector. It'll have 2/3, it's got 2/3 the angle, it'll have 2/3 the arc length, and it'll have 2/3 the area. So if you took sector AOB here and got 2/3 of its arc length, you'll get CD. If you took 2/3 of its area, you'll get the area COD. So when one sector is 2/3 of the other in terms of angle, it's 2/3 in area and it's 2/3 in arc length. So it's not really involving pi r squared at all, and it's not involving pi d, it's simple proportion. Get the fraction and apply it. So the basic thing is, if you ratio the angles between the two sectors, that tells you what fraction you've got. Or you could ratio the arcs, or you could ratio the areas, depending on the information it gives you. If it gives you the angles, ratio the angles. If it tells you the arcs, both arcs, ratio the arcs. Similarly, tells you the areas, ratio the areas. Whatever information it tells you. So here it tells you the angles, 60 and 90. Tells you AB is 24. You have to figure out arc CD. It's simply 60 90ths, that's the 2/3, is the ratio of the angles. So that will be the ratio of the arcs. So if you take the arc length 24 and get 2/3 of it as it is here, 2/3 of that 24, it will tell you the arc length CD is 16. So it doesn't involve pi d, it doesn't involve pi r squared, it's just recognising that 60 degrees is 2/3 of 90, so your arc length is 2/3 of 24. If you're using a calculator, you don't have to cancel down, but it shows you it's non-calculator. Second example, this time it tells you the arc lengths. So CD's 16, AB's 24. You've got the two arc lengths, you can ratio the arcs to find out the fraction. It wants to know the area of COD based on this 180. So what you do is you ratio 16 to 24. Again, of course, that's 2/3. So you basically want 2/3 of the 180. Divide by 3, multiply by 2. It's 120 square centimetres. None of that involved pi d or pi r squared. It's simple proportion. Look at the information they give you and figure out what fraction one sector is of the other. So these will be worksheets. If you click the link description, you get access to the worksheets. They will have the answers on them. And it covers all these things on sectors. There's also notes covering all the videos in the area. So we've covered triangles, quadrilaterals, circles, and that's sectors. Next video is in surface area of solids. Hope you found this video useful.